So let's try and write some tests, see what it's like. The first approach we're going to use is just an ad hoc testing approach where I'm just going to try and make something up and write code just using what we already know how to do. So we have our sort class. The sort method does nothing, and we have test sort, which has a main method that also does nothing. So to write my test, I'm a big fan of helper methods, as you probably know. So I'm going to make a method called test sort, and it is going to test the sort.sort method. Okay, to do that, we need to generate some input, feed it to the sort method, and check that it is what we expect. So to do that, I will create an array of strings. Let's use this random sentence generator here. I have an egg, good, okay. I like that. Okay, I have an, egg. Okay, so I have an egg. I'll take away the period. I mean, it doesn't much matter. And I'll lowercase the I. Okay, just to keep things simple. So that's our input. So then we're going to call sort.sort on input. And then I also need to have what I expect set aside. Okay, so what I do here in this case is an is going to be the first thing when we sort, and then egg, then have I. Oh, cool. That's pretty fun. An egg have I. Fancy. So we got string input, I have an egg, and string expected, and egg have I. After we call sort.sort on input, we then need to check and make sure that the output is correct. In other words, that after this method runs, that the input string has actually changed to match expected. Okay, so when I say output here, sort.sort does not return anything, right? It's void. So in this case, the output is just whatever's in the array after it executes. So what we can do is perhaps something like this. If input is not equal to expected, then we can yell at the user and say, error, there seems to be a problem, okay, with sort.sort. And then in main, we will call this method. Oops, could have just used tab completion and saved myself some typing. Oh, that's crazy looking. All right, and here we go. So we've just written a test. Let's try running it. Okay, error. There seems to be a problem with sort.sort. That seems good, right? Sort doesn't do anything. And our test has revealed that grim fact. Now, I have bad news for you. There's actually a pretty significant bug in test sort itself. Now, how can that be? Seems a little surprising. Well, the issue here is that we're abusing the not equals to operator. Now, this might be something you don't know, but the way not equals works is when we try executing that line of code, what it does is actually compare the contents of this memory box here, input and expected, and it says, are these the same? Are they pointing at the same object? So back to the mystery of the walrus, an object is considered equal in Java only if it has the same address, if these arrows are pointing at the same thing. Let me make that a little more clear visually in case that didn't make sense in words. Let's suppose we modify expected so that it actually just matches input, just for the sake of argument real quick. So let's rerun our debugger. When we get to this line, if we look at our code, they both say I have an egg. Great. Now, however, when I move to the next line, whenever I say step into the next line of code, we see that the result of this if statement was actually true, that it did consider them not equal, right? Even though they have the same information. And the reason is these two addresses are not the same. Okay, so that's a big problem. There's a bug in our test. Seems scary. And that's a real world issue. Tests can have bugs. So let's put expected back. So to fix this bug, I can do something like, I can use a method called arrays.equals. Sorry, I guess it's java.util.arrays.equals. And then I can give it my two arrays, and this will do what you expect. It actually checks all of the items in the array, and that's just something I happen to know about, and that'll save me a little time. So now if I run my code, it will properly say there seems to be a problem with sort.sort, and now my test code actually works. Now, one last thing I want to change about this code is that this error message is not very descriptive. So if I was using this as an autograder for students, they'd be very upset. Like, that's just a problem? That's all you're telling me? Why not give me some more information? Well, to do that, I would need to maybe iterate through my array and say for int I equals 0, I is less than input.length, I plus equals 1, if input I dot equals expected I, and that is not the case. So if any two don't match, then I can do something like, so what I had before was correct, it just wasn't very useful. And so now by adding this, we get a little more information. We can say something like mismatch in position I expected, I expected, oh, there's my plus sign I was missing. Okay, expected I. Okay, the point here is that this is tedious, by the way. The fact that this seems annoying is exactly the point. Expected, but got input I. Okay, there might be some bugs here. Maybe it. Okay, so let's try running this. And when we run it, we get mismatch, expected and but got I, all this stuff. Okay, well maybe we only want one to happen. So if we do have a mismatch, we only need to report the first one. And this will be the first mismatch. Okay, so that's what a test might look like in an ad hoc fashion. Now in the next video, you'll see how this can be made much better when we use JUnit.